G'day folks, just time for a little machining quickie. I'm just doing some bolt patterns for a friend's little Kawasaki Ninja Power go-kart project. Taking this little Chinesium adapter, evident by the marks on the thing. I don't know what happened there, it looks like the tap missed the damn hole and went off on its own little adventure. But I'm going to adapt that to this, and the holes and the bolts don't line up, so it's basically a stepped adapter that I've machined out of a piece of high-grade steel, and yeah, we're going to see what we can do. Well, actually, it's recycled steel. I didn't use a piece of high-grade for this, it wasn't big enough. But it is just a recycled piece of steel, a piece of old, I think it was a refrigerant dryer end plate, old Danfoss thing. So, yeah, reasonable grade steel. This is aluminum. That's plated steel, Chinesium again. They're not that expensive, but we'll see how we go. These are 11mm holes, these are 8mm threaded holes, so in this case I'm going to be doing 4x68mm PCD, point center distance, and they are also going to be countersunk, flush with the surface or just below. So this can be bolted to that, and then the sprocket can go on top and not sit on top of the heads of the screws. It's got all this bearing surface. And that is just going to have some big mushroom head screws, basically. I guess you call them that. I can't remember. The exact term eludes me, don't worry. I'm having a brain fart right here. But yeah, they're going to have some big panhead style cap screws, countersunk, or not countersunk, panhead or mushroom head high tensile bolts. We'll just call them that. Anyway, right now I've done the centering on the y-axis, which is basically moving towards me and away from me. Using this wobble pin. If I move this, once it's running, if I move this a little bit further, the pin's going to flick out. And you're only moving in a fraction of a millimetre at a time, like 0.000501. Just a tiny little bit, and the second it flicks out, stop. I'm going to 0x when it does that. Then I'm going to go all the way to the other side, get it to flick out the same way, and then when you do that, you basically press half, and then select the axis you want to halve, which in this case is X. So I'm going to fire this thing up and show you that if I can set the camera up somewhere. And I will warn you, this is loud. This is a very crusty old China mill drill, and it's not quiet. It's not like a nice slick new Bridgeport or anything, so it's what I got to work with. But yeah, this is my little mill setup, and the lathe over there. No readout on that, I just sort of go by the feel of it, and a lot of testing. It's a very old 1940s South Bend. It's not a lot of work. Even if they made a tiny little DRO that'd fit it, I don't think I'd modify it or butcher it, drill holes in it just to mount it. That thing works fine as it is. So yeah, this is what I've got. If I plug that monitor in, I can put drawings on it or whatever. It's quite handy. So yeah, this is one of the many little jobs that I can do. And as you can see, this machine does get some use. It needs a really good clean right now. There's just mountains of swarf. Well, not mountains, but still. For a little mill drill, this thing does a lot more work than it should. Okay, I was trying to prop the camera up on something, and that's not working, so to hell with that idea. Let's freehand it. Bring it in. It's not wiggling now, but it's just touching, and I'm going to move this very slowly. There we go. Zero. All the way back across, going to negative. I'm just moving at fractions. There we go. So we go half axis, X. A bit hard to see. Yeah, this thing's noisy. This isn't the easiest to see, but that's a bit better. Yeah. Basically, once you see the pin start to straighten up, slow right down and bring it in just a little fraction at a time. Just creep it in, even if you have to use both hands. No shame in that. Just creep it in and just wait till it just pushes out. Or just kicks out. You'll see it kick out, or it'll just start basically spinning, spinning, whatever. They're not the most accurate of things, honestly. Use a test indicator if it's really crucial, but in this case there's clearance on everything, so yeah, it's good enough for what I'm doing. I'm going to go through and double check that. I always do them twice when I'm using a wiggler for something like this. Now it's given me one reading. I'm going to go through and just compare it, check it, and make sure that it's right. So I'll do that, and then we'll get on to actually setting PCD. If your DRO doesn't have that function, this walkthrough is probably going to be completely useless to you, but these generally do, all modern ones do. In inches, well, someone's going to say, oh, you don't tell us it in inches. I'm not doing inches. I used to work with inches in the foundry, on and off. Like, I learned both metric and imperial systems working in a foundry, because a lot of the equipment was older than I was, well, older than my mother was, hell, even older than my grandfather in some cases. Yeah, we had bronze furnaces that dated back to the World War I, with all kinds of crazy stuff. But yeah, I'm doing metric, so yeah. I will try and read stuff out in imperial if it's applicable, like pounds, that kind of thing, but really, metric's fairly common these days, and I strongly recommend using it. Okay, now that we've found our centre, and I've double checked that everything checked out fine, the main thing with these things is don't go too fast, because it's not stopping you from over travelling. So if you go really slow, get this perfect, and then get impatient and just rapid this thing in, and as soon as it flicks out you stop, you're going to be off centre. So your speed and feed and stopping times have to be the same in each axis, and it's close enough for simple bolt patterns like this. Now if I wanted to true this up with a boring head or something, no, I'd use a test indicator, but this is just a bolt pattern for basically a sprocket which already has drilled but crude 11mm holes for the 10mm bolts. I'm probably going to make some sleeves to go through there anyway, and God only knows what this abomination is like. So yeah, we'll be fine. We'll be just fine. I hope that lines up. I have checked it and it looks fairly good, but if it doesn't, well, that's where the drill comes out and we open the holes up. Anyway, what I've got to do next is tool change, and we're going to go PCD mode, which is basically, I'm going to tell it, well, I can set it now, I don't have to change the tool, but basically 68mm PCD, so we enter PCD mode, which is this one here. Let's see that clear enough. So we do that. So center starting, yep, center zeroed, we know that's good. Let's see if I can remember how to drive this thing. Yep. Diameter, so we're not 100 mil, we are 68, so we go 68 point. So 68 PCD, correct. Number of holes, 4. Easy. Like, this thing is so easy to use. It's like setting a microwave. Number of holes, enter. No, not. Ah, I thought it said 45 holes. No. Yeah, starting angle 45 degrees, correct. So we're basically that way. Hopefully we won't hit the chuck jaws. Again, it's been a while since I've driven one of these to do this sort of thing, but yeah, it's pretty good. That looks a bit better. There we go, now you can see it. Start angle, yep. Ending angle, yep. Send it. Alright, now what it's given you is some coordinates. You want those to go to 0. So we're negative 24 on the x-axis and negative 24 on the y-axis. So you basically bring those to 0. So I'm going to wind the y-axis across. Now, I know I've got the wobble pin still in there, but he's out of the way. Wind him down to 0. I think this is actually going to screw me up. I might have set that chuck wrong. I can always start my starting angle though. Yeah, because this is going to start me right over the top of that chuck jaw, which we can't do. So, I've got to go back and change the starting angle. Oh, don't tell me I lost my 0. Close that. No, we are still good. Yep. Yeah, it still saves you 0. I forgot about these things. It's been a while since I've done this. So, we've got our 0. Probably don't even have to return it to full absolute 0. I might just double check that. But basically what's happened is it's starting at 45 degrees, so it's going to put us basically a drill bit right through the chuck jaw. So I want to start at 0 degrees, or 180 or something like that. I'll have to play around with that. If I was holding it from the outside, something like that, I could do that and do the second set of holes all in one. The second set have to be tapped, but I'm going to be rigid tapping with this thing. Main thing is how to set this, and I'm still trying to relearn what I learned about these things a while ago. So yeah, all I've got to do is change my starting angle. 45 degrees is, yeah, obviously off, so I want 90 degrees. Yeah, it'd be 90. So if we go PCD, center 0, diameter is 68, number 4 holes, let's say 90. Ending angle 90. So hole 1, yes, that looks better. X-axis is 0. And then, oops, no, you're an idiot. Y-axis, first hole is here. That's more like it. Yeah. I don't know why it was set to 45 degree start angle, but say if these jaws weren't in the way and I wanted to do the second set of holes for this, I'd just go back and go from 90 degrees to 45. So you got 8mm holes at 68 PCD, and then M10 tapped holes, so drill 6.8mm at 89.5 PCD. Easy. So yeah, it lets you correct your mess ups on the fly. It's pretty forgiving. So if I wind him all the way to 0, or thereabouts, 0.005, which it just seems to like to sit on, I could throw my center drill in here and drill it. Or center drill then main drill. I do recommend center drill for PCDs and things because again you want the bolts to all line up. You don't have to take a cordless drill and ream the holes out. Center drill everything and then main drill, or center drill main drill, center drill main drill if you don't mind doing tool changes, and honestly I generally do it that way. Okay, I'm pilot drilling the whole lot, just, you know, because this thing takes so long to decelerate. I've got to play with the parameters on this drive. Although this drive is actually a universal drive I use for all kinds of projects, so it's kind of set, but when I get a drive to install in a box on this thing, it's going to have actual reverse, like DC braking. So yeah, tool changes get a bit time consuming. Anyway, for what it is, it's working, and what I'm doing is going through. I've already done hole 1 and hole 2, and all you do is just scroll through here. Hole 4, 3, 2, already done 2, so hole 3, already good on x-axis. Now on y-axis, we just keep bringing it back a little bit. 3-4mm all the way back to basically 0. There we go. And don't worry, these scales are absolute, so they're a glass scale. Wherever it goes, I mean, if you go too far, yes, there's backlash in the screws, but you can still take it back. I mean, the position of the table is still absolute. Just keep your gibs ever so slightly tightened. Nobody likes sloppy gibs. So just doing that and playing with it has made X wander a tiny bit. But again, I'm being a bit pedantic about something which doesn't really need it. So anyway, start the drive. Yeah, nothing's perfect on this machine. I should really have the head way down, but it's a bit late for that. Yeah, this drive's only running, yeah, it's not going to be happy. So that's done. It's wandered a bit. This DRO should be on a much better mill. Let's do hole 4. Bring that across. Yeah, this motor's only rated at 415, I'm running on 240, so this drive's doing double duty, trying to keep it going. Yeah, that one hasn't wandered. Whoop. Good. Yeah, that works. Now for the main drill. And yes, I am using very expensive cutting oil. I don't know where my WD-40 went. And I'm not going to turn the coolant on because it just makes an absolute mess. Very good. That's main drill. I think I've got a 8mm stub drill in the drawer. Hopefully it lines up with this thing, which, yeah, as I said, is probably should have gone in the scrap bin, but you know, quality control ain't paying much attention in China these days. Alright, well, once you've done your pilot drilling or whatever you got to do, it's just the same repetition. Once you, well, you got into hole number 4, so if you're doing 4 holes, all you do is press down again and it'll go back to number 1. So there's your coordinates, 0 them out, it'll leave you there, drill your hole through and continue. And I'm going to do the same thing, except I'm going to do a tool change and mill out this web here in sections. I mean, as long as it's got enough to keep it centered, that's really all I can do. I mean, there's nothing in there that I can't bolt through from the other side, so what we're dealing with is, yeah, I've got to countersink and probably actually machine the heads down on some cap screws. This is actually getting quite complicated. But, yeah, I'll see what I can do with it. At least this doesn't come all the way through to the back. There's a little bit of a step there where I made a bit of a bugger up on the turning side of it, and it only gets about halfway, so even if the head does protrude inside, this isn't going to hit it, so I think we're fine. It's a very close call. It's adapters. That's adapters 101. You're going to have some pretty close calls when it comes to adapting 2 very close bolt pitches together with minimal thickness too. Remember, this has very minimal space to have bolt heads and things hanging out, which is why I'm using countersunk and button head screws and all that kind of stuff. So anyway, I'm going to go through and basically do my main drilling, then I'm going to do a tool change and mill that out and continue on from there. Basically index it after deburring, just double check the centering and drill my M10 holes for this. I'll drill and tap, and it's also going to have lock nuts on the back if there's enough space. there might not be. I could always mill radius in here just to clear nuts, but again, I don't want to take too much material off. We'll see how we go. And these are fairly cheap. It's like $20 or something like that, so if it has to happen, it has to happen. Otherwise, Loctite everything. Or make a custom adapter from scratch, and I'll just take it to a work I know and a job that I know and get them to EDM a key slot in it, because I don't really have a broaching machine. Okay, so now that I've got the holes drilled, I've worked out if I'd go 2.5mm sort of each way and just clean out that part of this centering ring, it'll do just fine. I mean, what's the worst that can happen? At least I get head clearance. These screws have to be countersunk, that's the main thing. These have to be, those don't necessarily have to be, which is why I'm using these button heads, but if necessary that can be countersunk, and countersunk screws can be fitted later. It's only like $2.50 worth of screws, nothing. So yeah, if I go 2.5mm each way, there's just enough clearance to get that head in there. So I'm again using the PCD function. I'm just going to go next hole, mill that out, next hole, mill that out, and then change over to countersink and countersink each of them. And that will do the most complicated part. The rest of them are basically, well, just straight. They're going to be indexed. I'm obviously going to have to index this, and they're just going to be drill and tap. There we go, that looks pretty cool. That'll clear the head just nicely. I'll just go through and deburr it with a little file. Should be pretty good. Next, countersink. And again, all I'm doing is using the coordinates and basically zeroing on the axis, and then just basically going 2.5mm cut, 2.5mm cut. Just take some of that material out. It's going to require some deburring, but that's about it. It's crude but effective, and it will clear these countersunk heads. There we go. It just makes it, the countersink's too big, but it just makes it without hitting these little steps that I've machined on there. At fairly low speed. Close enough. Spindle wobble. Tighten that up a little bit more. Okay, well that turned out reasonably good. Yeah, the screws are too long. I do have to trim them down by about 4mm. If I'd gone with 20s instead of 25s, it would have been fine, but yeah, I'd rather go longer than shorter. So yeah, it looks good. They do sit in nicely. The next step is to set it back up and actually do the M10 tapped holes. That shall be tonight or tomorrow. And yes, this hole here, where you can see they haven't even cleaned up the outside of the bar stock completely, and the tap's also gone runaway, or something's gone runaway. probably the tap, but that is definitely off a little bit. I had to hone that hole out, ream it out, and that's why there are witness marks on here to line the thing up. So this only goes on one way. It is concentric, but because of that hole, yeah. But hey, it's a cheap piece of crap Chinese thing, and it is what it is. I'll also find some high tensile screws for that too, although I'm sure Ben's already got them, but I'll supply extra screws anyway. So it's not terrible. Next job is, well, yeah, set up and drill and tap the main sprocket and we're done. Should clean up pretty good. Okay, so everything's cleaned up and deburred, and I've done the first set of holes. All cleaned up, indexed, close as it needs to be. Let's do the second set, which is 89.5 PCD. Still got the 0, based on the chuck anyway, close enough given these are just roughly drilled, just like this horror show. Let's set the PCD. So we're back at absolute. I don't think I have to go to 0, but I will anyway. Actually, it should be saved in the machine. But yeah, we'll start at 0. Center our tool with respect to the chuck, which has already been zeroed, it's clamped. The whole lot's absolute glass scale encoders. Close enough for what I'm doing. So let's go back to PCD. Center is 0. Diameter. Now, 89.5. Enter. Yep. Number of holes 4, yes. Starting angle 90 degrees. So again, we're starting 90 degrees, not 45, drilling through the chuck or the existing hole. Ending angle 90 degrees. Beautiful. Hole number 1. Got the gibs tightened up fairly tight. I can't see much with that down display there, but alright, so second set of holes, piloting them, and they're going to be tapped M10, so I can use the 10mm button head screws. And again, just using the same principle. You set your actual PCD diameter, number of holes, whether it's 2, 4, 6, 8, 10, as many holes as you want. You do it really fine, like lots and lots and lots of little 4mm holes, or 4 10mm holes. You can do whatever you want. It makes it quite easy. You don't need a dividing head. A dividing head plus a DRO is a really good combination. I would look for a small dividing head when I get a bigger milling machine. But for now, all I'm really doing is basically saving up a budget for a decent milling vise. I don't really have a decent milling vise. My milling vise is basically like one of those woodworking vices, and they kind of suck. Yeah, that's my current milling vise. That's not a milling vise, that's a woodworker's vise. So yeah. This is where the Patreon and what do you call it, PayPal donations go to. They don't go to anything else. They go to helping keep this shop afloat and bring you some more content, interesting content too. So yeah, if you feel like donating, helping the channel out, there's links in the description. Again, it's I need to add some stuff to the Patreon thing. I'm thinking maybe a question and answer kind of session, something like that. So yeah, if you're interested, you're interested. If you're not, well, it doesn't matter. You can always watch, and I will never have a video like this behind a paywall. I'm not one of those channels. I won't paywall this kind of thing, but I might have a patrons only question and answer session or something like that, but that's about it. Main thing is high speed internet, high speed machine tools, good machine tools and equipment, and being able to buy projects like this. This is paid for by patrons, that's paid for by patrons. It's basically a case of, yeah, let's have some fun in the machine shop. I'm going to show you how to tap a hole in one of these things, and that's about it. Alright, just before I go, let's try some rigid tapping with the crappy old milling machine. This probably isn't going to end very well, but we'll try it. Give a bit of oil. Speed down. I'm using a gun flute tap, so it's not too bad. It's working pretty good. Reverse. It's doing alright. And don't worry, I've done thousands of holes using a Jacob's chuck. I've never actually used a proper tapping attachment. Never had a problem. Beautiful. Next hole. Y-axis 0. X-axis 0. Hole number 2. Well, actually, it's hole number 4 technically. I think I'm going a bit too far. The delay on this VFD kind of sucks. Yeah, it's jacked the... It bottomed out and jacked the workpiece up a little bit. Problem solved. Yeah, the delay, the braking on this thing is non-existent. It's not set up for that. When I get a proper VFD just for this machine, which is rated properly, I'll have instant braking essentially like the lathe, which is essentially, well, yeah, reverse current braking is basically instantaneous. Yeah, it works. Anyway, that's pretty much all for that one. Once this is done, we'll bolt it together and it works. Thanks for watching, and stay tuned for more. Hopefully I can get some better equipment. I need an octopod for this camera so I can set it on the milling table instead of having to use capacitors and empty ammo packets as camera tripods. But that'll happen soon. Yeah, thanks for watching and stay tuned for more. Alright, well that's it right there. I'll leave it up to the customer to trim or do whatever he wants with the bolts. And yeah, done. It's a good little adapter. I've got some other screws in there just for the hell of it. They're just ones I had lying around. It's sort of like a shallow, regular socket head. These are a proper button head. So supply them all, and that's done. Ready to deliver. Well, ready to be picked up. So yeah, it's just a little bit of drilling, tapping, and how to use a DRO basically to do PCD using. It's incredibly easy actually, but you kind of get the gist of it. And yeah, I'll look for more projects and things to do. I might actually talking to a friend, IT guy that I used to work around and work with. He's found a lathe with a seized spindle that needs some TLC, but it's a nice big one of the earlier Taiwanese ones, Hurless branded. Well, Hurless is with the machinery importer, but it's a got a quick change gearbox and everything on it, so might salvage that if it's still available. He said he can get it for free, so can't really lose, even if it is a write-off. But yeah, get it for free and do it up if it's still available. So yeah, we'll look at machining bronze bearings for a little engine lathe. I'm assuming that's what they are. He said that they're bronze bearings and it's locked up solid, but it looks like more like a modern spindle, which you'd use tapered roller bearings. So not sure. If it is tapered roller bearings, that's nice because they're easy to get. It's a lot easier than making custom bronze bearings and regrinding a spindle. Anyway, thanks for watching. I'm going to have a bit of a clean up in here and move on to the next project. Stay tuned for more.